Hello, my name is Tom, and today I'll be talking to you about the challenges of building an API service based off our learnings from Svix and other API services out there. So who am I? I'm the founder and CEO of Svix. I'm an open source developer and maintainer. I've been coding since I was 9 years old, and I previously led teams at Samsung and the Israeli Intelligence Corps. As for Svix, it's the enterprise-ready webhook service. That means we help companies send webhooks and drive workflows on top of their applications. Some of our customers include Brex and the long-term stock exchange, and we're backed by Y Combinator, Aleph, and amazing founders and CTOs. This talk is about what we knew and what we wish we knew before starting an API service. It's based on our learning from Svix and other services out there. Your requirements may differ, so apply reasonable judgment. Also, some of it apply to non-API as well, but the stakes are higher when building an API, so they definitely apply for an API. But if I forgot to mention anything, please do let me know via email or Twitter. So before we begin, let me share some thoughts around what I see around development. So one of the most important things, I think, is to keep things simple. Complexity is the biggest enemy. You must avoid it if possible. It prevents you from moving fast. It increases your likelihood of failure. And it's also hard to reason about. It's very, when you see a very simple design, it's very hard to understand exactly what's going on there. While if it's very complex, it's impossible to try to find out what went wrong on how to improve it. Another topic is technical debt. So like real debt, there is good debt and there's bad debt. Good debt lets you buy a house and gives you money in advance. Bad debt cripples you and makes sure that your wallet is always empty and you're always struggling. So take technical debt with caution, but don't shy away from it. It's a very useful tool. Another thing, before you begin, you have to understand your tech stack. Different technology comes with different trade-offs. Do you care about consistency? Do you care about availability? You have to know the tools you use and their limitations, and everything we're going to talk about from here forward is going to rely on that understanding. So the now immortal motto of Y Combinator is make something people want. And in order to make something people want, you have to know your customers and what they want. So you have to ask, what do they want? What do they care about? What would they hate? Really have the curiosity of a child. And similar to understanding your tech stack, if you don't understand what your customers want, you're essentially playing a game where you don't know the rules. So it's extremely important. And again, everything we're going to build on, and we're going to build on this for the rest of the talk. A good example, or maybe counterexample, is the famous Henry Ford quote, which is, if I asked people what they wanted, they would have asked for a faster horse. So I'm not saying ask your customers and let them dictate your features or your roadmap, but definitely you need to ask your customers and talk to them and better understand what they need. And related to that, it's not about what you're building, really. It's about what you enable. So as you can see from the background image, no one wants a drill, or maybe some people do. But what people really want is holes. So you have to figure out what your customers want and help them get there. A drill is one way to get there. Maybe there's another way to get holes. Maybe you have to, you can sell like IKEA. They sell furniture with holes pre-drilled, so you can assemble it yourself. So it's really about figuring out what your customers want and giving it to them rather than obsessing about the tools and the solution. But you also need to understand the solution that you're building. You have to have a very deep understanding of what you're building. You have to be flexible and dynamic about how you're approaching it. Again, I can see I'm quoting a lot today, but as Mike Tyson once said, everyone has a plan until they get punched in the mouth. So it's great to plan, but don't overdo it. Just maintain flexibility, maintain your ability to change and to adapt to whatever your customers and the market dictate. So for example, if you're building an authentication service, it's important to understand the solution very well. So you need to know that you shouldn't store passwords in plain text. And you have to know the best practices around choosing passwords and strength estimators and whatever. But you also have to maintain the flexibility of, maybe adding single sign-on later on, or auth, or any one of those, social integrations, or link, email linking in order to sign in. So all of those kind of things, you have to have very strong domain expertise in order to know what is coming and how to build the foundations correct. And you have to make sure to set the right foundations. So if you really understand what you're building, you can make those right estimates, and you can think of how the product could look like in the future. Again, don't presume that you know what your customers will want, but you can still have a very good idea of how, what direction it will go. So if we go back to the authentication example, we know realistically that we're going to have more authentication providers, just because this is becoming a norm. So you can plan for that ahead of time. But with that being said, embrace the unknown. You can't have analysis paralysis, sorry. But if you have a very good understanding of what you're building and you have good instincts, it's going to be fine. So just move forward, just keep those things in mind. Another related thought about complexity, which is especially important for API businesses, is API complexity. So API is the equivalent of the UI for normal SaaS. So you need to strive for simplicity and learn to say no. A lot of time your customers will ask you for some really specific things that are only relevant for them, and it's only because they've designed their solution in a special way currently. But maybe you can offer something else that is, more generic and applies to more people. So be careful about saying yes, and it's absolutely fine to say no as long as you understand their problem and you can help them find a better solution. Be explicit about what you offer in the API, because you can't break it, and if you build it, you're stuck with it. And especially watch out for accidental flexibility. So one thing that we did wrong is that we have UIDs. So essentially a customer can set their own identifiers for entities. We let people use them interchangeably with normal Svix IDs, which is great. But we also enabled it for messages, which was a mistake. It's not really useful. And now we have an API that is actually very expensive to run, and it's not that useful. So it's much better to avoid it if possible. And also you can, one way to give people flexibility is to just, give them, let them do a lot. So for example, if you can offer them, to embed CSS and just add their own custom CSS into your product. That may sound like a great idea, because then you give them the ultimate ability to customize everything. But this also means that you can accidentally break, break the UI for a lot of random customers, whenever you make a change. So this flexibility is actually very expensive, and you really don't want to do it. And the last thing, you don't want to leak implementation details. You may use a NoSQL database today, may switch to a SQL database tomorrow. You don't know, so it's much better to abstract away from that and really focus on the value that you're giving rather than your current implementation. Again, understand your product and understand where you're going from here, and that will help you make the right decisions. Another question is, how do you deploy? That can make the whole difference for a lot of your design decisions. Are you SaaS? Are you on-prem? Are you both? Are you hybrid? Are you just running on AWS or maybe also Google Cloud Platform? Do you only use Postgres, maybe Mongo? Do you have any other runtime dependencies? This will really change how you should design your software. And it's really important to understand from the beginning, what is your deployment method? How do you serve your customers, and focus on one of them? You can focus on more if you want, but it's really just makes things exponentially harder. And it's, on-prem and SaaS are essentially two different products with very different requirements. To quote Linus, bad programmers worry about code. Good programmers worry about data structures and their relationships. So the quote is a bit out of context, but I think it works well here. Because what I'm trying to say is that you should choose your data layer wisely. You should store your data in the way that makes sense to you, in a database that works for your use case. Because making making bad decisions here can really affect you down the line. It's just very important to keep that in mind for your scalability, but also for your flexibility around queries and everything else that your customers may want. Unfortunately, even though you're doing this amazing job and you got everything right and you understand the product and you understand your customers, people will still use it wrong. So make it easy to use it right. Make it hard to use it wrong. Expect it to be used wrongly and be ready for that. So for example, we add rate limiting for new customers, just so they know that if their approach is very, very like API call heavy from day one, they're probably doing it wrong. And then they can lift it, but at least it's like a break to just, shake them back into reality. You also need to find your North Star. So like, what is the most important thing that you're building as a product, as a business, as a service? For us, it's reliability. What does reliability mean? We never lose a message once accepted. So you send us a message that you want to send. We send your response. We got it. That's it. We can't lose it. We persist it immediately. It's replicated across multiple databases. We know it's there. And we avoid downtime at all costs. Like, downtime is something we just don't do. It can happen. Hasn't happened so far, luckily, but it can happen, obviously. But we really work hard on adding like a lot of layers of redundancy to make sure that downtime does not affect us. And we also want to be very fast and very low latency. But it's in this order. We never lose a message, we never do downtime, and then we care about speed. The first we do at all costs. The other ones we try our best to minimize as much as possible. Another thing is be dependable. As an API service, you're part of their product. If you go down or something goes wrong, they go down, and something goes wrong for them with their customers. So one of the most important things is for them to know that they can trust the solution and they can trust the team. How do you become more dependable? So first of all, you monitor everything. You have full visibility into your system. You know when something is going to go wrong before it does. It helps you to quickly detect issues. It helps you to quickly fix them. It helps you to understand anomalies way before they even start to form. In addition to monitoring, also have alerting to actually like notify you and wake you up when something is wrong. You also want to have logs everywhere. You want to be able to detect anomalies in logs as well, not just in usage. You want to have a lot of information when something goes wrong. Like, you really want to be able to dig deep. And if something goes wrong, at least it will only go wrong once, because you figure out what went wrong and you know how to fix it, and you can deploy a fix immediately. It's very similar to monitoring though, but one small difference is that you need to watch out not to log personally identifying information or personal health information, or really any other sensitive information like a password for whatever reason, or user data. So it's always, like one of the more naive login implementations is just like, okay, cool, there was a request. Let's just log the body and the response and the headers and everything. But headers may contain authentication headers, and the body may contain personal customer information. So you definitely don't want to log those. You can have some systems in place if you want. You can encrypt it before adding to the log, or encrypt the sensitive areas, or store them separately before adding them to the logs, and then only have access through authorized systems in order to access this potentially sensitive information. But at the very least, in the beginning, filter everything out. Another thing to think about is reliability. Again, you don't want to go down. So you have to have a lot of redundancies in place, multiple database replicas, multiple API replicas, multiple regions, multiple availability zones within regions. Give your customers the best ability to not go down, because you're not building. If Slack goes down, it sucks. It's not great. If people lose hours of work, you get the works down. It goes down, even worse. It's really annoying. But at the end of the day, it's not embarrassing for your customers. But if your customers rely on you and you're the reason why they go down, that's a very bad experience. So make sure that you do whatever you can to avoid going down. Also have no single point of failure. So things fail, unfortunately. Clouds fail, AWS fails, GCP fails. Try to reduce as possible the places where things can go wrong. Another thing that people often skip, but you should definitely not, is test your systems, both under load and continuously. We have fake users that just run on our staging and deployment and production environment all the time and make sure that everything works as expected. This is in addition to normal testing that we have and automated testing that we have. And I think it's immensely important in order to understand, in order to find out if things go wrong way before they do. And also try to really consciously seek out failure cases and address them. Try to think, where can things go wrong? How can things go wrong? And how you can address them before they do. I said that multiple times, but I think it deserves a slide of its own. You want to ensure high availability. If you are down, your customers are down. Again, in most cases, maybe in some cases you're an API company where it's not the case. But in most cases, or in many cases, it is the case. So watch out. Take this honor and responsibility seriously, and make sure that you deliver on your promise to stay up. You also want to have accountability. First of all, so your customers can know, of all the effort that you've put into making sure that everything works well. But also that they know that sometimes things don't go well, and they can see that, and they can know that, and they can trust you. The most basic thing to do is have a public status page. You want to update it and be quick and transparent about failures. I don't want to name specific companies, but every now and then you see on Hacker News, people ranting about a company where everything is down, everything is red, you cannot log in, you can dashboards are down, everything is down, but the status page is all green. So don't be that person. Make sure to update everything, preferably automatically. So when things, when you're monitoring detects a problem, just update the status page. But even if not automatically, at least have it as the first line of your disaster response or incident response checklist. Be quick and transparent. Reach out to affected parties immediately. So again, first line, let everyone know if it's system wide. If it's very specific and just affects one specific customer, make sure to figure out who that is and reach out to them. But anyhow, if you're affected multiple customers, update the status page, let people know. Do postmortems to understand failures. It's standard practice to do them in public, but I think even doing them in private, just yourself and the team, is already a very good start, because you want to understand and you want to improve and you want to give your customers a good summary of what went wrong. Maybe we are annoying in that regard, but we actually keep on pinging customers in real time as if they're part of our team. So this one went down. So when it's public, it's just a status page. But when it's someone that's specifically affected, we send them a message. Hey, this, we noticed elevated errors. Just check on your end if it's something you did wrong, but we're checking on our end. Oh, it's actually our problem. Update number 2. And then, we know a solution. Fix is deployed in staging, and then fix is deployed in prod. We keep on updating them, and then after that, we let them know exactly the summary of what went wrong and how we addressed it and everything that might be relevant for them to know. But it's really just holding yourself to the highest standard. You be the service you want to use. So if you use a service and they're doing a terrible job, don't be them. Be the best version of yourself that you can be. Another thing that is very important for an API, and I mentioned it earlier, is not to break it. So how do you not break API? First of all, just don't break it. Look at the code. Don't change code that breaks API. But another important aspect of it is really to test everything and have very defined behaviors, not in text, not in manuals, but in actual code that checks all of these behaviors and makes sure that everything is locked down. You have regression tests to hermetically lock everything. So if something changes, you will know. Related to that, you want to ensure a high code coverage. Use a code coverage tool and make sure that you're hitting high numbers. Though code coverage is not enough. A lot of times there's like a lot of state that is passed to a specific function, and then that state that passed like to a different function, and their behaviors can be very different based on that state. So you'll have full coverage, but it actually, like the permutations of possible scenarios are not going to be represented. I have like a lot of strong opinions on how to do like proper testing and how to design code in order to be well tested, but that's not outside of the scope of this talk, because you'll get like a 1 hour rant. But it's really important to always test and continuously test, because if you have a test suite that you only run once you remember, it's going to be too late. You already broke API for someone. And one hill that I'm willing to die on is the use of strict type checking. I know some people don't like it. I honestly don't understand how you can build a robust product without it. So we encode a lot of our constraints in the type system in order to make sure that everything is solid, everything is consistent, and everything is the way we want it to be. And I guess like a small shout out to Rust for really letting us define what we want to the extent that we want it. Disaster recovery is extremely important. So we did everything right. We have monitoring, we have logging, we do all the tests, manual, automatic. We locked everything down, regression tests, everything we just talked about. But disasters happen. Maybe AWS is down for whatever reason. Maybe your account got blocked. I don't know, like things happen. And you have to hope for the best, but really prepare for the worst. So have offsite backups, have point-in-time recovery, and have like a long list of what can go wrong and how to address them. And it doesn't mean that you need to, you don't need to, first of all, to go too crazy. Like you don't need to have a backup plan in case like an asteroid hits the Earth and kills all life as we know it. But you do need to have some backup plans. So if you have like servers in an otherwise sensitive country that may ban you at some point for whatever reason, have more backups, have like a plan to how to recover from that, have training to make sure that you know how to restore from backups and like a lot of people actually back up, never try to restore, and then are very surprised to find out once they need a restore that actually all the data is missing and the backups were bad. And so restoring from backups is as important as backing up, because otherwise you don't know it actually works. And also you want to train in order to make sure to reduce the time it takes you to restore from a backup. So those things are extremely important. And yeah, one last thing you want to train on, I guess, is like deploying all of the infrastructure from scratch. You never know what can happen to your production account. You never know what can happen to, just things can go wrong, and just like be able to recover as quickly as possible to resume normal services for your customers. You also need to know your dependencies. You're only as strong as your weakest link, unfortunately. So you have to use only trusted tools from trusted sources. You need to make sure that your tools are dependable. So built by strong technical teams with as good of practices as you, because, if you're building this amazing tool and you did everything we just discussed, but you're using a cloud provider that is actually like, an old machine at someone's home, you will go down no matter what you do. So you need to make sure and not audit, but like verify that the tools that you use are up to the standards that you want. And that goes both for open source dependencies, on-prem dependencies, and also hosted services. Evaluate your dependencies yourself. So we sometimes take big bets on tools like Rust on the server, which is fairly new. It's actually quite robust, and like people have been using it in production for a few years, but it's still not as common. But before going there, we made sure to evaluate all the libraries that we use, see how the community treats them. Are they being used in production? If they're fairly new, like what do we think about the code base, about the dependencies, everything. So we really evaluate our dependencies to make sure that we rely on them. And we make big bets, as I said, but we make careful big bets. So essentially in one line, it's okay to be bold as long as you're also prudent and careful. Just something to keep in mind. Another thing is you need to know the metrics that your customers care about. Your potentially core infrastructure for your customers, and they may care about one thing and you may care about another, and you need to make sure that you're aligned and you can provide for what they want. So do they care about uptime in terms of percentage per month? So as long as we optimize, as I said, for like 0 downtime, but maybe our customers are okay if we're down for 1 hour of maintenance every week. Maybe that's fine, as long as like we let them know in advance the hour, and that's okay. One maybe no 0 downtime. They cannot have like any scheduled downtime. They need like continuous service, but they're okay if one request in every 1 million requests like fails. Maybe that's fine for them. So you need to like better understand that. Do they care about the latency or the throughput or both? If they say they care about the latency, does that mean like 5 seconds, 1 second, 10 milliseconds? Where do they stand there? Do they care about strong or eventual consistency? Does the data, if they write a message and then immediately try to read it, does it need to actually return a correct result, or can it just say not found and only actually, return the correct result after multiple seconds, or maybe it will delay the request for multiple seconds? So without knowing what your customers care about, you can't make sure that you're making them happy. So the first thing, again, is to understand your customers and know what they care about, even those specific things. And then the next topic is security, a very important one. The first part is application security. You need, it goes without saying, it's one of the most important things. So familiarize yourself with OWASP, top 10 and best practices around security in general, correct password handling if you're doing it yourself, strict authorization and restrictions, like make sure that everything is locked down, everything is tested to be locked down, and you're following industry best practices. You also need to worry about operational security. How do you handle vulnerability and dependencies? How quickly do you patch systems? You need to have security and dependency scanners. You need to have security training for the team so they know not to give, if you send them an email asking for the password, they know not to give it to you because that's probably like phishing or scam or like an escalation. And you need to make sure that you encrypt all the data in transit and at rest. Security is about having multiple lines of defense and just make sure that every line is strong. You need to be strict and lock down, both in terms of your operations, but also in terms of application. We follow the common least privilege access control, guideline. I forgot the word for that. But essentially what that means is that people have the least access as they possibly need. No one should have direct access to prod. Like, we don't have anything like that. What we actually do is every query and code that touches production goes through code review. So if you want to run like a custom query to figure something out, you have to commit it into Git, like have it review, commit it, have all the tests run, although there won't be probably tests for a query, and then only then deploy it to production in the same way that we deploy everything else. Limit the capabilities of all the accounts with access. Obviously, we'll still have a root access, but you shouldn't be using it day to day. And have paper trail. So log all access and all operations on all accounts, especially if they access user information, especially if they change production, although you shouldn't be able to change production. You also need to think about how you isolate data between customers. Are you a multi-tenant system or a single-tenant system? Can one customer access another's data by accident? Like, how is that enforced? Do we use row-level security in Postgres? Do we have a different database? Do we use, name spacing and a centralized access in code? You have to understand those things, and make sure that you have a good security story, and not story in the fabricated sense, but story in the really robust solution sense. And have strong enforcement for all of those things. Like, never, no one should be able to bypass that by accident in code. You want to make security easy for your customers. So they should have role-based access control. So they can have like a billing user that can only change billing, and they can have like a view user or an admin user that can add accounts. You should really, take that into consideration. You should enable key rotation and scoped keys. Scoped keys, just like to give them some keys limited access. It doesn't always make sense, but in some cases it does. And it needs, it's good to give your customers like the tools they need in order to limit access on their systems. Educate them about security with your service. So like, what are the pitfalls? What can go wrong? And make it hard to get security wrong. So one thing that we did like back in the days, like in a different product, it wasn't actually security related, but I really like it, is you need to pass like a special environment variable that is called I really know what I'm doing. And then you need to set like a random value there, like that, predefined. So it really shows that you read the docs, you're explicitly stating that you know what you're doing, and only then you can go around like limitations. This is maybe a bit extreme, but having a function that is prefixed bit, I really know what I'm doing, is maybe not the end of the world. It just, you have to figure out what works for your service now. And I touched on the main things, but you need to make sure that you know security best practices, like really familiarize yourself, like get help, like ask people that know what they're doing to advise you. There is a lot that can go wrong in every single way. Like security is damn hard because, like when you write code, if it works, it works. I mean, okay, maybe there are corner cases, whatever, but it mostly works and you can test it and then it works. With security, it will work, but maybe there's a hole and there's like no way to know, especially for the untrained eye. So make sure that you familiarize yourself with everything because security issues are rampant, even in the best tools out there. Even just like to take an example from what we do, a lot of webhook implementations are doing it wrong. They're signing stuff incorrectly. So not signing all the headers that are relevant, not signing all the data, changing the data before signing, using SHA-1 or other deprecated, known to be not broken, but like weak hash functions. So things can really go wrong and you need to know security in order to get it right. One thing as well that you realize when running like an API service is that it's really just more than just code. There's actually a lot of DevOps, a lot of infrastructure. It's if you write a CLI tool or like a local tool, mostly it's gonna work. But when you run a service, you have to make sure that the service operates well and operates correctly and operates with everything that we discussed in mind. So your infrastructure is a core part of your service. You have to treat it like code, use infrastructure like code. Don't touch the UI when modifying stuff. Audit, review, version control, all of your infrastructure. And then like when it comes to question, do you build or do you buy? I prefer buy as long as it passes the evaluation we touched on before. And buy also means like use open source software. But it's really better to let the experts do what they do best. We let AWS manage a lot of things for us. We can probably do a great job in all of them, but they have the capacity to make sure that everything is as tight as we want it to be. Again, as long as we define it correctly. So we delegate a lot of that to them, a lot of that management to them. You need to prepare for the future, but build for the present. As I said, like your product will grow, but don't be delusional and start like building at Google scale from day one. So you really just want to like build for the now, but just be aware that the future is coming and you need to be ready for it. That takes place in like various areas. One place is scalability. So you want to make it scalable, but not too much. You want to build for like 2x, maybe 5x your current expected scale, but like have a path in mind for like 10xing, 20xing, 100xing, where you currently are. We actually made this mistake early on, where we saw a lot of traction and our traction growing, and we're just like, okay, cool. We know, everything is going great. Let's just like 10x what we had. Like, let's redesign things in a way that really scales all the way we wanted. And we paid a great price for it in terms of, man hours and development hours that we really didn't need, because we're still not 10,000x like where we were but when we did it. And it would have been much better if we just did like 10x, maybe even rather than 1,000. And just like maintain the flexibility of like a small startup. Multi-region and multi-environment may be relevant for you, maybe not, but it's definitely important to keep in mind. You may want to add like for GDPR, you may want to add like one in Europe, maybe for CCPA, one in the US, maybe for India, they have like their own requirements, maybe one in India, Australia has requirements. So it's better to understand that you may have to support multiple regions from day one and have not even like placeholders, but just like have a design that lends itself to that. And related, you will probably want to have multiple environments. So your customers may want to have a testing environment, a staging environment, a production environment. So keep those in mind and plan for it. Another thing is, like we said, role-based access control. That's something that you want for your systems, but it's also something that your customers will probably want. They will probably want different users, different roles, all in the same account. It's much easier to keep that in mind from the start rather than trying to tack it on later on after you already built everything with one user, one account in mind. You want to be flexible and extendable. Your customers are developers, so like give them the tools to build whatever they want, like cool things on top of you, automation on top of you, their own wrappers are on top of you. And also realize that they're like you, they're inventors. They make new things. So they may want to use it differently than how you want to use it, and steer them to the right direction, but also maybe give them flexibility where it makes sense. Related to that is like sending webhooks, and you should be using Svix for that. But really the nice thing about webhooks is that it gives them the possibility to build automation on top of everything that you're building in a very lightweight and easy way, like without building a very deep integration, without installing like deep SDKs. So it's really great. So the DevTool equivalent of a UX is developer experience. You have to be very intentional about the user experience, the same way you would be when building a UI. Like if you look at a terrible UI and you use like a terrible UI, like, oh my God, I never want to use it again. And it's the same with DevTools. So you really want to care, like you really should care about the developer experience. One part of it is being consistent with your API. And there are two main ways to maintain consistency. One is to define very strict API standards, write them down, document them, have testing to like ensure that everything is correct. And that's great. That's probably the better alternative. But the fast and easy alternative is BDFL, which is Benevolent Dictator for Life. It's just like an open source term, but essentially means one person designs everything and make sure, you need to make sure that that person is good and internally consistent. But once you have one person, it's always going to be the same kind of style, the same, the same structure, the same everything. So it's great to, it's one cool hack to be quick about doing that. And you can start with BDFL and then like, set API standards and set things in stones in other ways. Great docs really make the difference, both an overview and a deep dive, both for beginners and for advanced. Docs are extremely important for developers. We like reading docs, or we like looking at docs. Show how your API should be used, but don't assume people know your product and the problem inside out. There's like the curse of knowledge, which is, essentially means that when you know too much about something, it's very hard for you to put yourself in the shoes of a beginner. But just be aware of that. Maybe use new team members, new joiners, and ask them to, go through the docs and see like if they have any thoughts. Don't forget about tutorials. Guide developers through common uses. Get them started quickly. Have easy onboarding and highlight really cool features. If docs are the compass, tutorials are the map. Even developers need support. So maybe your API isn't clear, maybe they found a bug or want a feature, maybe they just need help. Make it easy to debug and report issues. Don't fall into the developer trap, where you think developers just like will solve their own issues. No, developers need help and they need support, especially if your product is new. It's very important to have a great API. It's much better to have an awesome SDK. Look at how much smaller this is and cleaner this is, and much harder to get wrong. Just like a small bonus round. We talked about on-prem earlier. Honestly, I would advise against it. It's really, really a lot of work. So really think carefully before you go down this route. You need to support multiple environments, so AWS, GCP, Kubernetes, Docker, like how they deploy things to prod. You need a lot more configurations. You need like potentially different databases, even more documentation, because all of a sudden they're going to do more operations on their own. And you have to think about data migrations. You can no longer just copy to a different database, run a migration, copy back, do anything fancy. You cannot do any workarounds on your own with ops because now they're managing stuff. You can do manage on-prem, which is a much better solution. But again, it comes with challenges. You have less control over everything. So it's something to be aware of. So closing words, the main takeaway is it's not all about code. You have to understand that you have support, you have docs, you have operations, you have a lot of things that are just as important as this kernel of beautiful code that you wrote. And all the things that I mentioned here worked for us and worked for other API founders that I've asked before writing this presentation and other services I learned from over the years. But your mileage may vary, especially if something is missing. Let me know, tweet at Tom Hacohen, and I'll make sure to update the slides and upload them again. But otherwise, that's it. I think, this gets you covered, and you can go ahead and build an awesome API service. Let me know if you have any questions. You can go to our website, www.svix.com. Twitter is SvixHQ. Ping us if you have any questions. And we also have a lot of open source components, including our core webhook dispatcher. So go to our repo, start, watch, open tickets, share, send us code contributions. We would love that. That's it. Thank you.